right, let's go. As of now, if you walk up past the front of the session, I will antagonize you. So that's good. You are all very, very welcome by me personally to be here. This is the first time I'm at SQL Day Poland in person. I've done the virtual one, but yeah, it's not the same thing. So I'm very happy to be here. Today, the next 60 minutes, well, I'm going to try for 55 because I am the one that stands between you and lunch. I'm going to try to give you some input on what is Direct Lake for Power BI. That's what I'm going to be trying to do. Mainly, I'm also not the guy that's here to sell you something. I'm the guy that's here to tell you, this is great, but there are a few things you need to be aware of. So those are the things that I'm going to try to focus on. If you want to move over there, there's still some more wall space there. Please do. But let's get started. First thing, I know for a fact how expensive food and coffee and all these things are. So sponsors, they help pay for it. If you go by their booths, if you talk to them, you'll find that all of them have something very interesting to say. So please do visit them because they are what keeps this affordable for you. Now, let's go. Myself, my name is Jagere. Bonus points if you can pronounce my last name correctly. Hubert did a fair attempt last night. It's getting there. Yes, after a few beers. Maybe that's the secret, yeah. So myself, I work for a small software company called Microsoft. They're based out of Seattle, only like 300,000 people in there. And I work for a team called CAT. It's not a cat adoring team. It's basically a customer advisory team. It means we go out there, we talk to customers, we help customers, and we help unblock their problems. But basically, we also take their feedback with us so we can help other customers solve the same problems. If you want to move over this side, that more people can come in, that would be helpful as well. Thank you. Now, I help run a user group in Belgium, datamines.be. We do very similar things to the data community Poland. Hello. It means that, well, we try to put things on, hello, hi. It means we try to put things together for people, bring them together to share their passion for data, share their passion and enthusiasm. Hello, hi. Now, if you want to find me afterwards, if you want to ask questions, I still need to install the Hoover app, so I will do that during lunch. But basically, if you can spell my name and pronounce it, you can find me on the social channels. Be patient. I don't respond instantly. And unfortunately, I am also not a big fan of pie charts. I'm sorry. I'm not a big fan of pie charts, but that is not the scope of the day, luckily. Today, we're here to talk about Direct Lake, but I need to briefly touch on something called Fabric and OneLake first. Then, well, I want you to understand Direct Lake and what that thing actually is. But obviously, it wouldn't be a fun session if I didn't try to take it for a spin. So that's what we're going to be doing today. Now, Fabric, I'm assuming that most of you attended the keynote session with Chris today. It's essentially something we launched in May 2023, last year. So it's going onto a full year into public preview. And essentially, it's an all-in-one product. It's the SaaSification of data analytics. And I vomit inside my mouth every time I say SaaSification, but it does sum it up really well. We've taken a lot of that complexity from Azure Platform as a Service, or even running VMs in Azure or on premises, and taken away a lot of that complexity for you, put everything into a single application, a single browser, to make it more easier for you, and also the people that have to govern that thing. Now, essentially, a lot of those boxes that you see there, they are very familiar, because we had components in Azure Platform as a Service. Data Factory is Azure Data Factory. Data engineering was what we had within Synapse. The only things that are net new are these little buckets called Data Activator. Are you doing a Data Activator session today, Lars? Okay, yeah. So there, yes? Tomorrow there's a session on Data Activator by Lars. Go look at it because it's actually kind of cool and kind of funky. But the emphasis is that we have all these things running on a central layer called OneLake. And the name itself says it because yes, Microsoft is really good at naming things. It is one virtual lake. It doesn't mean it's one physical thing. It is virtualized across the world. But for you, the user, it presents itself as OneLake. The good thing is, it's also running on one version of compute, those capacities, as we say. So regardless if you're running Spark, if you're running T-SQL, if you're running KQL, or if you're running analysis services queries, It all uses that same compute to connect to the same layer of data storage, OneLake. That's where your data physically lives. And we've standardized on something called Delta. Delta is an open source framework. If 10 years ago you would have said to me, open source and Microsoft, I would have laughed at you in your face. Today, it's a reality. We've adopted that open source framework to be able to use it and to be able to, well, reap the benefits of that thing. So Delta and Parquet underneath is the core of everything we do in OneLake. It is essentially optimized for all of those engines that we have. So everyone with me on Fabric? Do I need to go through more marketing slides? Yes, okay. Now, essentially what you had in Power BI before May 2023, you had two main modes of connectivity, storage modes, as you'd like to call them, where the one hand, you had direct query, which meant you had real-time data. For every query, you connected directly to the data source. Yes, I get real-time data. Jesus, it's slow, because it's not easy to get working right. On the other hand, well, you have import mode. Oh my God, this can be a lot faster than indirect query. Yes. The problem is I have to take all my data, copy that, do some transformations, dump it into memory. So yes, it's faster, but it takes a few hours typically for larger volumes of data to be imported and to be refreshed into your memory. So neither of them was actually a good fit, and I think 97% of the use cases we see out there is all import mode. Or well, in some days where people feel adventurous, they start combining the two of them together, where they say, we want to have that data imported, but for historical data or the latest data, we want to connect directly to the data source. All fair game. Now, the good thing with Fabric introduced, this thing called Direct Lake came into the picture. And Direct Lake is a bit of the best of both worlds. I know Chris flinged around some Madonna and some Taylor Swift quotes, but there is also Miley Cyrus who says it's the best of both worlds. Yes. It means effectively we're eliminating that refresh that you need for import mode, but we are combining it with the speed that you have with in-memory data. Does that mean it's the silver bullet solution and will magically solve all your needs? No. But it means it is actually a good way to improve on what you possibly have today. Now, if you wrap that up into a single slide, sorry, another marketing slide, that means that, well, you had direct query, slower for results, but it is connecting real-time to your data source and giving you the latest results you have there. You have import mode, it's faster because it's in memory, still the fastest thing out there, but it takes time to refresh that data. And then there's the other option that we have now called Direct Lake mode, where you skip the refresh, but we also enjoy the benefits of that in-memory speed. Now, why are we using something called Delta? Why are we using something called Parquet? Well, Parquet is essentially an industry standard. Slowly but steadily, there's an industry standard in those modern data file formats. You've got Hudi, Iceberg, Delta, and then there are some other niche ones out there, but the three main ones you see is Delta, Iceberg, and Hudi. We've chosen Delta because it works really well with what we were already doing today with analysis services and Power BI. And it's open. It means that anyone can contribute to that standard, where it's the standard and you see a lot of people from Databricks contributing to the Delta standards, but no one should be stopped from contributing to that standard as well. The good thing there is that it's column-oriented. If you've ever worked in SQL Server with column store indexes, it's exactly that same principle, where we take the data by the column and then we compress it, we encode it, we apply all that sorts of magic. It's what we do within Power BI. It's why we're able to get Power BI to produce that little data models, if you do it right, for larger volumes of data that you may have in your OLTP system. So that's the same thing we do there. And essentially, we've optimized the way that it stores data, it compresses data, and encodes the data. Which means that it's also really well suiting for something called pruning, only selecting a specific column or only selecting a specific row group within a file, only selecting a specific part of that data. It is horribly bad, well, no, it is really good at bulk operations, but it is horribly bad at single row inserts, updates, or deletes. It needs larger bulk operations to perform well. I see you taking photos. You get the slides afterwards. So you get them in better quality. You can take photos, but it's basically saving everyone some effort. Yes. Now, what is Parquet? I've got a very complex table, a very, very complex table. Let's compare apples and oranges. It means I have a table with apple, oranges, and pears. I've got some quantities, and I've got some customers. So Parquet is really good at just saying, from that entire table, just give me these two columns. But as I said, it is horrendously bad at updating a single row. But what do we do with that Parquet format, that Parquet file, and what do we do with the Delta standard? Let's go a little bit into some of the internals. We do something called dictionary encoding, especially in the case where we have string values, as here, apples and oranges. We say, okay, we're going to create a dictionary. Apples as of now is 1, oranges is 2, pears is 3. And then we replace that value and we say basically that is now 1, 2, 3, which means that we can compress it a lot better. But it doesn't stop at that, and I should have stopped at this one right here. So what I need to emphasize on is the bottom part here, where to store that data that we need now, we need about 30 characters, so bytes. Bytes, who the heck cares about bytes? If you go for billions of records, you will start to care about bytes. Now, just by doing that dictionary encoding, we can get it down to 20 bytes already, which is already a good step. But then, well, we also do something called bit packing, where we don't use a complete bit to store that data. We only use specific bits within that byte, which means we can get it down even further. But there is also something called run length encoding, and this is where it gets really cool, because we have apples and apples. We have apples and apples. And now, instead of writing that value, I think I said 1, down twice, well, we say 1 gets repeated 2 times. So instead of using that multiple times, we just say this value is now continued multiple times. And this is also where an age-old discussion of does sorting help with compression? Yes, but not always. But it means that, well, we reduce the amount of data that we need to write. So in the end, I get down to roughly about 5 bytes, 30 to 5, just by using that compression and that encoding mechanism. Small numbers. We'll get to the point. We also do something called V-ordering, and that's where we go away a bit of that open standard. That is a piece of proprietary logic by Microsoft. We've developed it, it's optimized for our engines, but it doesn't mean that it's not usable for other parts of the data analytics stack. And essentially, we optimize the way that we write data into the file onto disk. That's what we do there. We do some shuffling, some row group distribution, some encoding. We change the way that we write it so that it's optimized to be as small as possible. If you've ever heard anyone talk about Power BI and models, we've always said be as small as possible, because typically that also means you'll be able to get better results. Now, the good thing is it still complies to the open standard. That formula, that mechanism, how we write it is proprietary, but the end result doesn't break the open standard. So if you have a Databricks, for instance, or if you have another tool in your suite, they can still use that V-ordered file. And, well, it's also compatible with some other things like Z-ordering and time travel, those kind of things, but I'm keeping them out of scope for now because I want to focus on Direct Lake itself. The good thing there is it's not mutually exclusive. You can still use this, and you can still use this with other tools in your suite. Now, how does this look like if we take it for a spin? Internally at Microsoft, there's one of the cases that was used to test this was an internal sales database with roughly about 880 gigabytes in CSV files, because yes, that is the superior file format for storing all your data. But it means it's 880 gigabytes. If we turn that into plain vanilla Parquet files, we go down to 268 gigabytes. So by applying that columnar storage format, the things I explained to you from dictionary encoding and run length encoding, those kind of things, we go down significantly already. But then some of that V-ordering magic, well, we go down to 84 gigabytes. So if you compare the two of them, Parquet versus V-order, that's a reduction of 3.2. It means there's lots less of I/O, input-output, disk I/O needed to get the data that you actually need. It's smaller and it's more efficient for the engines that we have. Now, if I look at that for the actual examples that I have with me today, is I have roughly about 32 gigabytes in CSV files. Not big data, but enough to show you what I mean. If I load that in, it translates to a table of roughly 190 million records. So again, not big data, but enough to show you a point. If I load that in, I've just used plain vanilla pipelines because I didn't want to use Copilot to generate Python. That means I go down to a Parquet file, a Delta file of roughly about 5 gigabytes. So that reduction that you saw from the 880 gigabytes to the 84 gigabytes, well, that's that specific use case. Your mileage may vary. It's always dependent on the data, how unique it is, what the cardinality is, those kind of things, on how much compression you'll get. But you will always see a better compression. Well, I've not run into a case where it was not the case. Now, what is then essentially direct lake mode? What happens? Well, what you need to know is that in the beginning, nothing is loaded in memory. That memory is still the fastest thing out there to read data from, to get your results. SSDs are getting close, but still not memory. So when we start, nothing is loaded in memory. I've loaded in my data, it's all in my OneLake, nothing is there. Now, as soon as I start doing something, an operation called transcoding starts. And that means we get data from OneLake, the Delta, the Parquet files that have been stored, and I transcode it. Essentially, the way it's stored on disk needs some minor modifications to load it into memory to be compliant, to be working well with the VertiPack engine that we have for Power BI. So that transcoding operation is changing it from OneLake, storing it to what it actually needs for the engine. Okay, well, that's good. The thing here is that it only takes what it needs. If you have an SAP system with 725 columns and you only need 3 columns out of that table, well, you're only going to load those 3 columns into memory. Whereas with import mode, you'd need all 725 because everything needs to be loaded in memory or nothing. So that's where those differences already start to appear. Because a table can have a mix of a resident, is it loaded into memory, and non-resident, is it not loaded into memory. Not the entire table has to be loaded in memory. That's the key thing here that you need to keep in mind. But we also have something called eviction. And eviction means we drop it from memory for whatever reason. Not everything can stay perpetually loaded in memory because that would bankrupt us, basically. So for multiple reasons, the data has not been used in a while, or we need to make room for other data, or you decide to flush it. Well, those are reasons that we can drop data from that memory. That means, well, we have to repeat that operation again. We have to load it in, transcode that data, make it available again for Power BI. There is also one thing called fallback. That means if, well, for whatever reason, we cannot use Direct Lake, we're going to revert back to DirectQuery. DirectQuery to connect to the SQL endpoint of the Lakehouse or the warehouse, depending on what you're using. That means it's going to be slower, but it's still working. Otherwise, you would get errors. And I'm not sure about you, but I prefer giving my business users results rather than errors, even if they have to wait a bit longer. But there are some different opinions on that, I know. People. Now, there is also something called framing, and I'll get to that part. That is one of the big gotchas that you need to take away from this session today. Now, okay, let's go. Let's take this thing for a spin. Let's actually show you what it means. Now, what I have is, I have a, of course it disconnected. I have a workspace, and in that workspace, I have a semantic model, and bonus points for me for not saying dataset this time. And I can open that data model, and I can show you what I have here. It is a star schema, because star schema all the things, and you have one fact table with dimensions around it. That's essentially it. So you've got the fact table, and then the dimensions all around it. Now, could I have made this more complex? Yes, but for the use cases that I want to explain to you today, this is actually fairly okay. Now, I have a Lakehouse, And in that lakehouse, I've got those same tables that I mentioned before. I've got my fact table, and if I execute a query to show you how many records I have, I should get back those 190 million records that I promised you. And of course the thing canceled out, yes. Now, those 190 million records, as I said, it's big enough to not be working on 2 local Excel files. Now, that essentially is the basis for my model. What I can do is, well, I can start working with it. If I want to create a new model, I can go ahead and select New Semantic Model and start building it. It's the web designer. I think we've probably all seen Power BI before. What I'm interested in now is explaining you some of the specifics underneath. So I'll go into DAX Studio, an open source developer tool that you can get, and I want to get some information from the DMVs, the dynamic management views. The one that I'm particularly interested in right now is, well, what is actually loaded into memory. So I have my table names, my column names, some of the data types, and then these things are what I'm interested in here. I've got the dictionary size. Has it actually been using the dictionary encoding? Can I load it into memory? Is there an option to load it into memory? Yes or no? Is it already in memory? Yes or no? And then these 2 things called temperature and last access. Last access basically means when has the last query been executed against that column. Temperature is a magic value. No one knows exactly how it's calculated. Lars, unless you know, but I genuinely don't know. And the short version is the higher the better. That's the thing. The hotter it is, the more frequently it is used. That's the gist of it. So this means that, well, I'm connected to the model underneath of the report that I want to show you. But first, let's quiz you on this one first. So nothing is loaded into memory. Now, if I execute a query called total trips, the total trips measure, I'll give you the calculation, is a count rows of my trips table, my fact table. If I execute that, well, we're going to see we're going to see the 190 million records that I'm expecting. Now, if I execute that DMV again, please raise your hand. Will something be loaded into memory? Yes or no? Yes. No? I have no idea what this guy is talking about. I just want lunch. I'm glad you're honest. Thank you so much. Now, if I fix my query, if I run that, I'm sorry, nothing is loaded into memories because it can get the statistics from my table. The table itself knows, based on some of the file statistics, I know I have roughly 190 million records. I don't need to load anything into memory. So it was a trick question. Good. Excellent. I'm going to run another query. This is a sum of a column in my fact table. So I get a value. Same question. Is something loaded in memory? Yes? No? Is it beer o'clock already? Again, thank you for your honesty. Now, yes, that one column that I needed is now loaded into memory. So the rest of the fact table is not loaded. Only that specific thing. That's where the big difference is with import mode. Now, let's make it a bit more interesting. I've got a summarized column statement, and my Italian is poor, so I don't write Alberto and Marco level DAX, but it's a summarized column for my fact table, the 2 measures that I just executed. So we've already established there's one field loaded into memory. I'm going over to my bike table and my region dimension table to get one field of each. So I'm using 3 fields, basically, 4 fields. How many records will I have, how many columns will I have loaded into memory? 3? 3 columns? Okay. 5 columns? 7 columns? 42? Okay, let's look at what it is. Now, it's a star schema. So I have my fact table, and I have keys connecting the 2 of them. So I've now executed that query, and that means that I will have 7 fields loaded in there, because it's taking the values it needs to be returned in the query, the sum, well, the field that I needed, the column that I needed to do the sum measure. It also takes the field that I've put into the query itself called bike and region, but it figured out that, hey, that's in another table. I need to traverse the relationship. So it takes the primary key and the foreign key of both. So the only thing you'll see loaded in memory are if it's used in a measure, if it's used in a measure, yes, if it's used in the visualization, or if it's used to traverse the relationship between the two of them. That's a reason for it to be loaded into memory. Okay, so we've established that. Now, I'll show you an example within a Power BI report. Again, I am not a Power BI report designer, so please don't kill me on my report design. But it is good enough to show you something that I wanted to tell you. Because there is an important nuance here that I saw some people trip over when they started initially using Direct Lake mode. So Power BI Desktop still takes a ridiculous amount of time to load, which means that I have to keep bullshitting my way through the fact that it's still, all right, now it's there. Now, that means that I'm going to open up something called Performance Analyzer. If you've not used Performance Analyzer, it is a lifesaver if you want to troubleshoot your reports and figure out, well, how long are they using to do certain types of operations. And this is what I want to show here as well. I'm going to record this because I want to show you, well, how long does it take to use this lightning fast, best thing you've ever seen called Direct Lake mode to give you super performance when you open up reports. Are you ready? Yes. Okay, I am so convinced. Now, let's go. I will open up my report. Prepare to be blown away. Are you ready? Ah, okay, thank you. Now, let's go. Super. Yeah, this isn't. I think my demo is failing or something. Yeah. So what's happening here is this is the most beautiful report you've ever seen, obviously, but there are a few things happening here because, well, it took 7 seconds. Sorry. I really would have to bullshit my way around 7 minutes. This took 7 seconds. 7 seconds for this lightning fast performance for 39 million records. What the heck happened? Well, that's that transcoding operation. This is what's known as a cold start. We had to load that data from OneLake, transcode it, and dump it into memory. So now, theoretically, it should run faster. And this is where I hope the Wi-Fi works. I'll clear all the slicers so that I have all of the things that I need. And, well, yes, it's not as fast as I want it to be, but it got down to 1.8 seconds for the full table. What's happened here is because when I query a column, it takes the entire column and loads it into memory. We don't do, for now, partitioning on a column. That means if you want the column, you get the entire column, which still brings us to the age-old question, why do you need 20 years of historical data if you're only reporting on the last 2 years of sales? Let's put that aside from us. Now, it means that, okay, I have this now. If I start interacting with the report, well, this is all what I'm used to from import mode. Now it's loaded into memory, and I haven't had to do that refresh operation for import mode. If I go back to DAX Studio, if I look at this, well, it still means that only the things that I needed are actually loaded into memory, because other fields, for instance, for my trips table, well, they are not loaded into memory. They're all still non-resident. So it only takes what it needs. Gotcha number 1. Okay. Everyone still with me? Yes. All right. Now, let's go through these concepts of fallback and framing, because they are the two other big gotchas that I want you to be aware of. Framing essentially means that we're going to look at a certain point in time. It means that we're now going to lock ourselves to that particular piece, those particular sets of files. If a framing operation has not been done and you get new data, you will not see that new data reflected in your Power BI report. That's the gotcha right here. But this is also where there's a difference between there's also where there is a difference between default behavior and what I've got it set up here so I can explain it to you. Framing basically means that, well, you move a cursor. You now say, from this point in time, we'll start looking at the actual data. It tells that engine, that's the piece of data that you need for Direct Lake mode. That's the good thing. Now, why is this important? Well, for many reasons, we can have modifications in our Delta Lake. Inserts, updates, deletes, optimizations, vacuums, all of those things can happen. So our files can physically change. But it's still going to hold on to the point of data that it has until it's being pointed to say frame and now look at new data. This is very important. But it also means, and this is where the coin needs to drop, it also means you flush the cache. Everything that's loaded into memory is flushed. So the first person to start a query after that framing operation has been done has that cold start. Very important. That's where, again, I've seen some people be very surprised. And I mean, the default behavior is set up that it will automatically look for changes. Every single time something changes, it will frame. Is that good? Is that bad? I don't know your use cases, but typically, many of us, we work in a batch way of working. Most of us still run nightly batches and don't update throughout the day. Then why the heck would we need to update or we need to frame throughout the day if something would change? Typically, we do our ETL process or ELT, depending on how fancy you are. We load that data into those Delta tables, and then when we're done, well, then we say, now frame. Framing is essentially a refresh operation for Power BI. So anything you used before to refresh, the button, an API, a PowerShell script, whatever you were doing before, that still works. It's using the same mechanism. The difference is, instead of loading all the data in memory, well, it's dropping all the data out of memory. So that's the irony of things. But it is something you need to be really, really aware of, because that can get you by surprise. Now, I've got a short demo for this that we can look at. And here we go. That short demo means that I've got a report. Yes, I have a report. And this is where I really hope that Power BI Desktop is going to open up quicker than last time. And it's got a collection of my favorite YouTube channels. All of my favorite YouTube channels are in there, and I've stored them into one table, because obviously that's the way that you want to store that, in OneLake. But that report is, I still need to refresh it. That report, I will refresh it, make sure that I've got the last one. If I go in there, this is the same thing that's happening. So it needs to be collected, it needs to do that cold start, and I have 5 YouTube channels. These are my 5 favorite YouTube channels. Okay? These are all of my favorite YouTube channels. And now I have the same thing within a notebook, because I said, let's try a notebook. So if I run that select statement, I need to restart my pool. It means that, well, I'm going to get those 5 same things in there. The problem is that I want to make some changes, because I've changed my mind. I no longer think that those 5 are what I actually want. Now, as soon as that pool is started up, it should start connecting right now. Is Estera still here? Can I go complain about startup time? Now, as soon as that pool is ready to start, any day now, yeah, let's cancel that one. Let's run a delete statement, and let's hope that that works. I want to delete all of those values from that column. I want to delete everything. I have new favorite YouTube channels, and I want to insert those into. Don't think it's going to work. Now, I'll skip this part and I'll run you through it. Now, what I was going to do is show you the worst thing you can do in a data engineering practice is do row-level inserts, single-level inserts that do a transaction for every single thing. Why? Because it helps me set up for something, a point that I want to make afterwards. And it basically means that every single insert that I do is going to create a new file. So 5,000 of these transactions means 5,000 files. Bing, I said Bing, yes, for something called small file problem. It means that if you have too many small files, well, you're not going to get good performance out of this. And this would be something that I could show you. But essentially, when this would have been inserted and then deleted, if I would go into my Power BI report and I said refresh, it would still show me those 5 values that I had before, because I did not do that framing operation. I turned off the default setting. Only when I would go, let me cancel this to be sure, let me turn that off, only if I would go into my workspace and I said on that dataset semantic model, I do refresh now. As I said, I can do it with an API, PowerShell script, whatever I want. But then that would start refreshing, and typically it takes about 2 to 3 seconds. There, it's done already. That means that now, if I would go back into my report, it would show those 3 fields that I have in there, those 3 records that I updated. So again, the demo didn't work, but that stuff happens. But what exactly did I then change? What did I change about that default value? Well, in the settings, I'll take it a bit slower, is in the settings for your semantic model, there is a section called refresh. And by default, this is set to on. It means that every single time a new Parquet file is inserted into your OneLake or a Delta transaction log entry is made, this is going to detect it and it's going to do that framing operation, flush everything from cache. So yes, okay, you don't need to manage it, but you need to reload into cache, which isn't a good thing. So for the demo, I turned it to off. But also essentially, if you want to operationalize your ETL process a bit, well then turn it off and you control when it gets refreshed, when it gets framed. That's the way that I would handle it. That's the way that some of my colleagues also feel the same way about this thing. So that framing thing is important. Gotcha number 2. Keep in mind that that default value exists and that it might not work for your needs, especially if you want to use real-time streaming or micro-batching, frequently inserting new data. That's not going to be a good use case to get the best out of Direct Lake. Will we do something about it? Yes. I mean, we are discussing those things, but it is technically complex. But yes, we're actively considering those things and we're actively working on it. Now, let's look at fallback. Fallback, as I said before, is plan B. If I cannot use Direct Lake for whatever reason, I'm going to revert back to DirectQuery, which is slower, but real time. So let's do that. Now, let's say that I have a Power BI semantic model or an Excel file with some pivot tables, because yes, that's the way we work. What now? Shit. Dang it. A semantic model, it means that yes, it's going to execute DAX or MDX statements, whatever it's using. It's going to connect to that semantic model, and then that's going to make a decision. Can I do this with Direct Lake mode, yes or no? Or do I need to fall back? That's basically a decision that it makes. If it says, yes, I can do this, well, then it's going to do something called that vertiscan, that transcoding operation if it's necessary, but essentially look at the data that we have in the lake, use that Direct Lake format. If it cannot do it, well, then it's going to connect to the SQL endpoint of Lakehouse or Warehouse, depending on what you're using, and connect through DirectQuery. Essentially, if you want the full picture, it means that, well, if it's trying to do the vertiscan, if that data is not loaded in there, well, then it's going to get the data from the lake and then load it in memory. That's essentially the full picture. So again, it is there as an option as a plan B. The problem is that, I need to skip that demo, is that there are a few reasons why you can have fallback. The most important ones is something we call guardrails internally. They are based on the capacity that you have. So let's say that you've got the P1 or F64 equivalent. Well, that means that then you have a number of Parquet files before it starts tipping over. So if I point back to that anti-pattern that I tried to show you in the demo that failed with the insert statements, well, at some point in time, I would go over those 5,000 and it would always fall back to DirectQuery. I would no longer have Direct Lake mode. Same thing with row groups. I've not dived deep into the internals of the Delta file, but it uses something called row groups or chunks of data. So it basically means the amount of data also is sort of limited. But most importantly, well, you're also limited to the amount of records that you can have within that table. So 1,500 million records of data, 1.5 billion is the maximum size record count that you can have with a P1 capacity. And then, well, this one still applies. the one that we've known since forever with Power BI is that a single item can only take up to 25 gigabytes of memory. So it needs to stick within that boundary as well. So those are the resource-driven things that we put in place for protecting the infrastructure, basically, but also basically making sure that people don't spin up an F2 capacity to put 78 billion records into a direct lake mode model. So that table looks very impressive, and I've copy-pasted it over from a docs page that's linked below. So you can find that, and you can go look at it yourself to find the use case that applies best to you. But there are also some limitations. There are also some reasons why you would fall back to DirectQuery. The first one is a relationship between two tables on a date-time field. If you've ever followed a data modeling course, you should know that you don't make a relationship on a date-time field. But still, it doesn't work. Why? Because Delta doesn't deal with those data types well anyway. So we have to follow along with some of the Delta limitations too. And well, unfortunately, oh, I'm so sad. No calculated columns. This is the best thing that could happen. Calculated columns do not work with direct lake mode. It basically says itself, direct lake. We connect directly to the lake to load the data. If we use calculated columns, we layer something on top of it. So it doesn't work. It basically means that if you want to use it with direct lake mode, it has to be persisted in the lake, period. You can do some renaming, some basic things in your model, but you cannot create calculated columns or tables. And unfortunately, Lars and Pavel will contest to that, will confirm that. We get this back so many times. It's like, yeah, well, we built a model with calculated columns, so we want to do that in direct lake mode too. It's like, nope, it doesn't work. It's an anti-pattern. So that doesn't work. And there's also some other things with some complex Delta column types like binary or GUIDs, again, I'm so sad, that don't really work well with direct lake mode. They could potentially trip you over into fallback. But the big one is views. A view on a warehouse or a lakehouse will always go back to DirectQuery. Always fall back, because it's the same thing. You store the data in OneLake to then slap on an additional layer where you're doing all sorts of funky magic, probably because you don't get access to the warehouse or whatever, but it doesn't work because you're adding an additional layer in between something that wants to connect directly to the lake. So it doesn't work. Will we do it at some point? Probably, because people keep complaining about it too much, but it is not happening anytime soon. So those views don't work. The data needs to be persisted in the way you need it in the lake, apart from some renaming, technical names to user-friendly names. That you can still do, but like changing data types, concatenating two fields together will not work. It needs to be in the lake. Composite models, again, I'm so sad. Oh. Connecting that random Excel file with your budget files to my big beefy fact table doesn't work with direct lake mode. You will always go back to DirectQuery, always. That's the way it is. Now, how do you know if fallback is happening? How do you know when fallback is applied? Well, you can tell if it's slower. Rocket science, right there. No, that's the thing. I mean, typically, those results you've seen from a second, 2 seconds, maybe, you would see those go up to 4 or 5 seconds if you've got a fairly well-designed model. If your model is terrible, well, those numbers are probably going to go up as well. So that's one way of knowing. If you want a more scientific method, yes, there are options. Well, that performance analyzer thing you saw just before, it will show a DirectQuery entry. It will show a DirectQuery entry, which means that it's using that DirectQuery storage mode to connect to the SQL endpoint. The one thing you need to be aware of is that in certain scenarios, when you run it for the first time in a cold start, there's a bug/feature in Power BI Desktop where it for a split second shows DirectQuery and then it disappears again. Don't worry about that. It's when you're done loading, if there's still a DirectQuery entry, that's when you have DirectQuery. Fallback. Well, there are some other options. If you do a trace, connect with SQL Profiler, or if you're adventurous enough to do some funky stuff with extended events, you will see the same thing. You will see a DirectQuery begin and a DirectQuery end event in those logs. Or if you want to use bring your own log analytics, Azure Log Analytics, Azure Monitor integration, you will see that come. Now, depending on some of the behavior that you have, you might get an error in the report because you can control that behavior. You can say fallback, I don't want you. If you have disabled fallback and it still wants to try to fallback, guess what happens? You get an error. So it means that business users will get confused and they will call you. Not me, you. So that's the thing you need to keep in mind. So how do you actually control that fallback behavior? Now, I will show you what it actually means. Yeah. I will connect. No, well, yeah, I'll connect to my file here. Nope. I will connect to that model that I was using before, and I'm really sorry, but I'm not feeling like rotating my passwords, so I need to shut you off for a really split second. It's a demo tenant anyway, but it's too much of a hassle otherwise. All right. Now, I am in there, and I can connect to that model. I'm using Tabular Editor 2. It works perfectly fine. You can do the same thing with 3, but you can do it with the open source version. Now, essentially, on the model itself, there is a setting called Direct Lake Behavior. That setting has 3 options. Automatic, engine will decide for you. Engine a start, no problem. Engine a go, kaput. If you're into TikTok. My niece tells me it's a big thing. I genuinely don't know what it is. But if you set it to Direct Lake only, it will disable fallback. So the second it will try to do fallback, you will get an error, and I'll show you that one in a bit. If you want to say, yeah, no, I don't like that Direct Lake mode, I'm just going to direct query all the things. For whatever reason you'd want to do that, you can. Now, by default, it's set to automatic. I've probably left it there for another demo, so I'm going to leave it as is right now. So that means that, well, if I go in there, that means that I could get this reason, I could get this error when I'm trying to consume a report. This is what your business user would get. I am of the conviction that I want to limit the amount of errors that business users see. So if you set it to Direct Lake only, you want to be kind of sure that you're not going to get reasons to fall back. Now, the question there is, how do you know when it's going to fall back? Well, there is a DMV that you can use. There's also a blog post out there in the resources of the slides, which you can get by Sandeep Pawar. There are some DMVs that actually help you with this. It basically means that for all of the tables, for all of the columns that you have in there, well, it has a column called fallback reason. So up front, when you frame, it knows that it needs to fall back or not. So if this is set to anything else than 0, it's going to fall back. Now, what are the reasons? Sandeep has them all listed in his blog post too, but it means that, well, the table is not framed. It's not being refreshed. I'm trying to connect to a view. The table doesn't exist. Who knew that would get an error? Or I'm trying to use object level, row level security configured on a lakehouse or a warehouse. Another big gotcha. So that's one thing that you need to be aware of. The thing that I've also seen some people trip up over is, well, if the query needs to fall back because of one table, the whole query will fall back. If you're combining 2 tables and one of them needs to fall back, the entire thing will fall back to DirectQuery. So keep that in mind. Now, how do you optimize Delta for Direct Lake mode? How do you make it go faster? Well, essentially, that V order that I mentioned briefly in the beginning, that makes a big difference. I've seen examples come in before with people that come in with Delta files from Databricks, etc., which is on its own not bad, but it's lacking that V order thing, and it can give you a really, really big difference in that query performance in the beginning as well, and also with that cold start. So the good thing is that by default, well, it will it will do that for you. All of the engines that you have in Fabric will automatically write v-ordered data for you. But it doesn't have to be that way. The data doesn't physically have to be in your OneLake. You can also use a concept called shortcuts. I'm hoping someone has explained to you that before, where the data can sit in external AWS S3 buckets, or GCP cloud storage containers, or Azure Data Lake storage, or on premises in an S3 compatible storage. That data doesn't have to be physically in your OneLake, but it probably will be a bit slower because of reasons. The laws of physics apply that where it's closer, it needs to traverse less distance, well, the faster it's going to be done. So those are all design decisions that can play a big role, and you need to keep that in mind. Now, Direct Lake thrives on fewer, larger Parquet files. So those small files with one record in them, they will perform horribly bad. If I do some operations called optimizing in vacuum, combining those into fewer larger files, that will also help my query performance. But that's where we're getting into data engineering territory, and where I probably won't go deep dive level into it. But there are some options that you have within the browser itself or within notebooks to do optimizing. Compile those files together, or vacuum, remove some of the old files that I'm not using anymore anyway. Now, for me, I'm still not sold on streaming or small batch scenarios with Direct Lake mode because of that framing operation. I'm still not sold. That's the way it is. Now, the principle of lean models still applies. That SAP table with 725 columns, yeah, nice. But if you put that in Direct Lake and you only select 4 columns, you only load in those 4 columns. But what happens if some very ambitious user says, select star from SAP fact table? Everything gets loaded, and you'll be in trouble. So limiting the blast radius, and also, well, we get into a fluffy discussion of whether it's easier to use a star schema or not, well, that will apply very heavily there. Now, there is an option called warming the cache. I've just put in a link there. Essentially, you connect to the DMV that I've shown you after a normal day at work. You look at everything that's been loaded into memory, and then in the morning at 7 a.m., you say, query those columns, load it into memory, and then the first user will not have to do that cold start. Pretty simple, not that much effort, and it can make a difference. Now, common answers to common questions, hoping that I can eliminate some of the questions you have. Delta does not like spaces in object names. Any Power BI modeler that I've seen so far loves spaces in object names, tables, columns, those kind of things. The Delta file itself, the file in OneLake, cannot have a space in it. You can rename it in Power BI Desktop with Power BI Desktop or an external tool, whatever you want to use, and still add those spaces. But the file itself doesn't like object names with a space in it. You have to use something called a Delta table to be able to use Direct Lake mode. That's the thing. It's a hard requirement. But the good thing is that all of the experiences, modules, what are we calling them these days? Workloads. All of the workloads, they create those for you. You don't have to worry about those things. If you want to create them yourself, go ahead, but you don't have to. Now, for now, web modeling is still the recommended way to create and to manage those semantic models in Direct Lake mode. At the Fabric conference, we sneak peeked that you can also do it in Power BI Desktop, but it is, well, yes, I know. It is being updated there as well. It is coming, but right now it's not there. You can use external tools if you want to, but keep in mind that some things might blow up if you go too far, too fancy. Now, Direct Lake doesn't have any unique DAX limitations. Direct Lake doesn't have any specific things in DAX that don't work, but DirectQuery does. So if you fall back, those are the things that you need to keep in mind. Now, I'll skip that. No, definitely skip that. Now, what does this mean for my data modeling standard? How do I need to model my semantic models in Power BI? Star schemas. They are still the best way to get the highest mileage out of Direct Lake mode because it uses that same engine. It uses the same thing to keep you going. So star schemas, they will actually help you get further in that one. Now, to close off, there is a quote by my colleague in the CAT team called Matthew Roach. he has a Roach's maxim of data transformation. He basically says data should be transformed as far upstream as possible and as far downstream as necessary. Persisted in the lake at the latest. No more cheating with calculated columns. No more cheating with Power Query. It needs to be persisted in the lake, or it will not work with Direct Lake. That's basically the thing. Now, there's a bunch of resources in there. I've already uploaded the slides into the OneDrive that the organization asked me to share. If you want to get the slides as well, basically it's github.com/benediagere/presentations. You can find it. You can scan the QR code as well. But while people are scanning that, we still have 4 minutes for questions. Any questions?
Yeah, one question.
Yep.
Two copies of the data of a key column, yes? Because you have primary key of dictionary table and foreign key of a fact table.
Yeah.
If you denormalize the model to one big table, you will have only one copy. Isn't it a better way?
No, I cannot answer this question in 3 minutes. Basically, no. I have a dedicated session on this as well. Basically, if you do one big table, it's going to be slower to refresh. You're going to use more. You're going to use more CPU compute power. It's going to be a larger model size. Your DAX will be more complex, and you run a risk of getting wrong results. That's my reason why I'm not a fan of OBT, one big table models. Yeah. So yes, you duplicate that data, but there are clear results. If you're on that GitHub, look for a session at SQL Bits that I've done on the last day. That's the star schema all the things session. It goes into exactly that scenario. Yeah. Any other questions? Yes, in the back.
Thanks a lot. So my question is, what are the scenarios or situation where with my import mode model, I should think whether I should move it to Direct Lake mode?
Can I ask you a follow-up question? Did you read a blog post on SQLBI.com?
Yes, that's perfectly the situation. Because I have to keep in mind the thing that I need to refresh the semantic model if I want to keep it up to date. I need to think about the risk of fallback to direct query, and I need to maintain the optimization of the underlying tables.
In a point in time in the future, we will manage that for you, but today it's not. Essentially, the answer that I've always given my customers is, if it works, don't break it. If it works, don't. If it's not, if it works, don't bother. If you have an import model that's not giving you any issues, it's refreshing fine, don't bother. If you're running a direct query scenario that's running into issues, if you've got a very long refresh running for import mode, those are scenarios where you might look at Direct Lake. But if it's a model that is 1.2 gigabytes in size with 30 million records, no, don't bother re-engineering that. Yeah,
and that's the most.
Yeah,
that's the
import mode is still the easiest way to get good performance. Doesn't change. Yeah, I told you I'm not a sales guy, so sorry about that. Yeah.
Thank you. Thanks a lot.
Any other questions? Yes, go ahead, please.
I've got a question if time traveling is working with Direct Lake, or if not.
Time traveling is not working with Direct Lake, not yet.
Is it a plan to get it
yes.
When?
Do you want to get a date?
If possible.
No, we don't have a date. No, but it's something that we want to get to. But we also still have some things to cover in lakehouses and warehouses to give you proper time travel support. But the file itself can still time travel. So if you have that file that you've written with Fabric, you can still use time travel in Databricks where it works today, but not completely within Fabric today. No, but yes, it's one of the things we really want to get to. In the back, just shout the question, I'll repeat it. How does vacuuming help performance? Essentially, you get rid of the old files, and doesn't really help you with performance. It more protects you against those guardrails. That P1 capacity where you have 5,000 files. If you toss the old files you no longer need, well, you're not going to hit that. You're not going to hit that boundary. So especially in those micro batches or streaming scenarios, that's where you could more easily hit that limit. But purely performance-wise, vacuum is not going to help you. Optimize will, because it's going to combine into one single larger file. All right, we're at time. Enjoy lunch. If you have questions, I'll be here somewhere the rest of the day. Enjoy. Thank you.